Okay, in this video what I'm going to do is show you how to do a Spearmans correlation using SPSS. So remember, Spearmans correlation is the test, or the non-parametric test to look at the strength and significance of a relationship between two variables. So I've opened up a set of data here in SPSS. We've got gender, male or female, we've got age in years, we've got height in meters, we've got weight or body mass in kilograms, and we've got body mass index. And what I want to do in this analysis is look at the correlation between age and body mass or weight. And the hypothesis would be that as people get older, then they also get heavier as they age. And we're going to use a Spearmans correlation because I've looked at the distribution of these two variables, and body mass is normally distributed in this sample, but age is not. Age is not normally distributed. And of course they both have interval or ratio scaled, but because age is not normally distributed, then we have to use a non-parametric test to look at the relationship between these two variables. So to do the test, then we're going to go to Analyze, and we come down to Correlate, and we go to Bivariate. And then you're going to get a box that looks like this. I'll just bring those variables back across. And so you want to put into this box the variables that you want to look at the relationship between. So we'll put in age, and we'll put in weight. And down here you've got your three options. Normally when you first open up SPSS, then Pearson's will be selected, so just make sure you deselect Pearson's and that you select Spearmans correlation. You don't have to go into any of these menus, just make sure two-tailed is selected rather than one-tailed, and then you want to flag significant correlations for us as well, just to make our life a little bit easier. And then we'll hit OK. And you end up with a box that looks like this. So just like for the Pearson's correlation, we've got three different values. We've got the correlation coefficient, we've got the p-value or the significance value, and we've got the number of participants included in the analysis, number of data points included in the analysis. And then we've got this matrix where we've got the correlation between weight and weight, weight and age, age and weight, and age and age. Now obviously the correlation between weight and weight is absolutely perfect because that's what you'd expect at the same value, but there's no p-value there because it's a pointless correlation. For weight and age though, we can look at the values, and you can see here that we've got a correlation coefficient of 0.202. Now remember that the correlation coefficient is measured on a scale of -1, which would be a perfect negative correlation, to 0, no correlation at all, up to +1, which would be a perfect positive correlation. So we've got a value of 0.202, and that's not very close to 1 at all, it's very close to 0, so that suggests that there is very little relationship between weight and age in this sample of participants. Now if there's not much evidence of a relationship, as in a very strong relationship, then you're probably going to find that it's not significant. So if we look at this p-value down here, 0.260, well, that's not lower than 0.05, which is our magic threshold. So we would say that this is a non-significant correlation between weight and age in this sample. And then you've got 33 data points that have been included. So you can use these values now to support your results section and support the creation of figures to show that scatter plot in your results sections. And that's how to perform a Spearmans correlation coefficient test.